Hello, I'm going to show how to set up the DA16200 and 16600 as the simple UART interface into IOTCONNECT. The two devices that you see are a serial to USB adapter, as well as a DA16200 module, and I'm using a Windows PC. So to go ahead and get started, I'm going to open up the DA16200 Quick Start Guide. I go into the DA16200 SDK. I'm going to go to the Quick Start Guide. And then from here, we will walk through these instructions. The first step is to go ahead and connect your DA16200 to your PC. There are several great pictures here that show this connection. And I'm going to go ahead and start by connecting my power, my ground, my RX, and my TX to the device. Okay, now that that's connected, let's go ahead and start by downloading the tool under the DA16200 product page. So I'm going to click on that. Actually, I can just type in downloader tool. So this multi-downloader tool. When you click on it, you shouldn't have to sign in, but it is going to ask you if you want updates. I'm going to say no, not this time. I'm going to confirm, and it's going to download to my downloads folder. From here, you'll want to go ahead and extract this to your PC. I've already extracted that into a folder here, and there's my multi-downloader tool. Next thing I want to do is make sure I have the binary files that are in the repo. So under images, you'll see 4 images here. I went ahead and downloaded all of them, so make sure that when you click it, you select download raw file. That will download, and then you can move them into your folder. So I created a folder called PMOD binaries, and I've got all 4 of them here. 2 of them for the 16200 and 2 of them for the 16600. One is the bootloader, and the other is the actual application file. So let's go ahead and open up the downloader tool. First, we're going to make sure we have access to the COM port. So mine is COM13, and I'm going to go to settings. I will say that a good idea is that when you get this board out of the box, you should not need to download the bootloader, but I'm going to go through a complete refresh. That refresh would mean that I would want to clear all the non-volatile memory. This is where we store all of the parameters such as your Wi-Fi SSID and your IOTCONNECT credentials. So I went ahead and cleared all of that information. So we're starting fresh, and I'm going to go into settings. You can put in the addresses, or you can just say, I know I'm running free RTOS. I know I'm doing a 16200, so the tool automatically puts in the binary locations. When I select boot, I'm going to go into the binaries. I'm going to hit the F2 boot for the 200, and for the RTOS, I'm going to select it as well, and it's free RTOS. For the 16200, verify that, and I'm going to say done. Now I can just hit download, and this will go through the download process of putting the bootloader in, and now putting in the application code. All was successful, so let's now go ahead and close this application. So congratulations, your device is now programmed, and now we're going to um, talk a little bit about configuring the device towards your application. So through the program guide, you'll notice that the very first section is focused on configuring the Wi-Fi access point. And the steps in the manual go through basically a screen printout of exactly the types of commands that you'll be providing. And then last, you'll be setting up the application uh, that's residing in the DA16200 that's connecting into either Azure or AWS via IOTCONNECT. And that process is going to require, that we have a device name, and we have certificates for that device, and we know exactly what account we're connecting into. So we're going to step through all of these in the next few steps. But first, let's go ahead and create the device in IoT Connect. So I'm going to open up IoT Connect, and in my case, I'm going to the AWS POC IoT Connect. You may be going to console or avnet or portal.IoT Connect. I've got IoT Connect open, and the first thing we're going to need to do is import a template. Because the DA16200 could be used with any device with a UART, we're going to need a template specific to the device that we're connecting it to. In this case, we're going to show the STM32N6, an ST device. And from this, in these projects, we do include templates. I will find a template called N6UVC template. I'm going to download that template by selecting raw and downloading that template. I'm going to go back into IoT Connect, and I'm going to upload a template. So templates are within the devices for that specific device type. Here we're using a standard device, and I'm going to hit templates, and I'm going to say create template. I'm going to import a template, and I'm going to browse and select that file. So we've imported the template, and here is the parameters of that template for this particular application. The next step is going to be to create a device. So let me go back to devices. I'm going to say create device. I'm going to call this one MCL for my initials. N6, I'll just give it the same name. I'm going to select the entity, which I'm just going to say my top level entity, and I'm going to choose the that template that I just uploaded. In this case, we're going to auto-generate certificates. You can use your own certificates. So I'm just going to say save and view. So since we're on the AWS instance, AWS will generate those certificates. We can download those certificates from here. I can download my certificates, put them in the my downloads folder. And I'm going to also, I want to get all the credentials from this device. So there's a feature where I can get those from this location right here. So those two files that you had downloaded from the device screen were the certificates folder, which is a zip file, contains your key and your device certificate, and then asked you to download a config file, which is the new feature. It allows basically the JSON of all the device configurations, so you don't have to go back and forth to the IoT Connect's key vault. So let's go ahead and go back to the getting started guide. And we had mentioned we're going to have to first set up the Wi-Fi. So I do recommend that you use TerraTerm or your favorite serial terminal program. The reason I like TerraTerm is because I'm familiar with it, but also because there's a couple things I do want to caution you about on your settings. Okay, so now we're going to go into the serial port, select the right baud rate, which is going to be 230400 and 8 none 1, and do put in some transmit delay because we are going to be entering in some large certificates. and those certificates, we don't want them to be corrupted when they're copied and pasted. So now we should be communicating to the board. First command is net. I believe I was already in there. So let's go ahead and go into setup. We want to stop all the services and select your country. I'm going to look for my Wi-Fi access point. So I'm going to select my local one, put in my password, and we can set advanced Wi-Fi. That's only asking if we want to connect to a hidden SSID, and we'll say no. And then you can confirm your configuration. Next, we're going to make sure we're automatic IP type, and then we're going to confirm that. And then we're going to set up the SMTP configuration. I'm just going to accept the defaults for the time server. And then we're going to confirm our configuration. We'll allow fast connection. And it's going to reboot. You will probably see a failure to connect because we are not getting the correct time sync. So let's go ahead and reboot. Reboot. Now we got time sync and we're connected to the internet. So the terminal is now asking us if we had run the client setup, which we haven't done yet. So the application setup is very specific to your application and your device ID. So we're going to use those parameters that you had saved off when you created the device, and we're going to need to basically put in the commands. To one, we're going to have to write the certificates, and then we're going to have to put in our device ID, our CPID, our environment, and the authentication type. So a couple things to make this go a little bit easier for you is you can go ahead and copy these commands. And I'm going to go ahead and open up the configuration file that we had downloaded, and so you can take a look at that. So we're going to open this with just Notepad+. And the reason I do like Notepad+ is because I can easily control my end-of-line conversions. I'm going to put this to Windows because I will need those carriage return line feeds. We'll go ahead and start entering in the device certificates. So let's take a look at those real quick. The first thing you do is type cert status, which this is going to fail because I'm not in the net subcommand menus. So let's do that again. Cert status, and you're going to see a couple of things. One is that for MQTT, which is how we communicate to the cloud, the root CA and certificate and the private key are empty. It's okay that the root CA is empty because we can that is taken care of for you in the code, and because we know where you're connecting to, we can put in the correct root CA. The device certificate and the private key, though, are specific to your device, so we're going to have to enter those in. So let's look at the commands for that. The commands are going to be cert write cert1. Cert1 is the name of the device certificate. There's multiple locations, and it's going to basically say copy and paste that into the terminal and hit Control-C when you're done. So I'm going to go back to those certs that I extracted. So the first one is my device cert, and I'm going to right click and I'm going to open it with Notepad++. And again, I'm going to put this into Windows format. You may or may not have to do this depending on what you're using. To me, though, it's good to see what's happening with the characters that aren't shown. So I'm going to copy this. I'm going to right click in my terminal and paste it. Right click in my terminal and paste it. And this is going to go kind of slow because we put in the delay. But with the delay, we know that we're getting every single character in there, and we're not going to have any errors when we try to connect. Okay, so you can go ahead and hit Control-C, and it says cert write success. Now we're going to need to write the key, public key. So cert write key 1. And let's go ahead and find our key. I'm going to open this up with Notepad++, and I'm going to make sure that it's in the right Windows format. So I'm just going to copy this. I'm going to paste it. And here I'm writing my private key. Okay, I'm going to hit Control-C, write success. I'm going to look at my cert status. Cert status. And you'll see that both the certificate and the private key are found. The next steps are going to be to configure the IoTConnect credentials. In order to do that, we're going to use the IOTConnect _config command. And that's going to be, the first one's going to set the, whether we're connecting to AWS or Azure. One is AWS, two is Azure. The second is going to be setting the DUID, CPID, then the environment, and then the authentication type. We're using X509. With Azure, you could use symmetric key, but not really recommended. So let's go ahead and make this easy on ourselves. So I'm just going to copy these commands. I'll go back to my Notepad+. SDK is in here. AWS is where we're connecting CPID, environment, UID, DID. We're concerned with UID. This is the DUID. And for the fun of it, I'm just going to copy these commands in here. And I'm going to make sure that I put in the right names for these. So I know that my UID is MCLN6 PMOD 2. I know that my CPID is going to be the one that's in here. I know that my environment is going to be POC. So I can just copy that. And to make our lives a little easier, I'm going to put another character return line feed. Let's go ahead and look at these commands. The final command we will do is the setup command. This will take these variables and enter them into IoTConnect or into the application. By holding the Alt key down, I was able to select, and so let's just go ahead and copy this. And let the computer do the work. So all of those variables were entered. The IoTConnect client setup command was issued, and it entered in, or it assigned the correct values. The final command is going to be to go ahead and start IoTConnect, and this will automatically happen when you reboot. So if we check IoTConnect, we'll see that this device is now connected. There's no data that's really being sent yet because nothing's connected to the UART port, but it did establish connection with IoTConnect. So we can look at the commands available for IoTConnect in the net folder. So if we do IoTConnect _client question mark. We can see the types of commands that are available. And we can see that something was published. So if we go into our live data, I can see that this will get published. Now that we have the PMOD connected to IoTConnect, we don't really need the debug port to be still connected. to the device. But we do need our host controller to be connected into the PMOD. So what you see here is the two the PMOD interface coming from the edge of the board. This is the AT command interface, and at the top you'll see the debug interface, which has power, transmit, receive, and ground. So let's go ahead and disconnect the power, and we're going to go ahead and connect the AT command interface into the PMOD. So to do that, we're going to, we use the STMod interface, which has a UART along with power, and there are some adapters that you can use. And then finally, we'll connect the power pin. I'm leaving the debug interface on just so that we can see what's happening. But what we can now do is get power to our device. So now that the board is powered, we can see the messages coming into IOTCONNECT. Here we have an application where we're looking at objects with the camera, and so if I point this as an object such as myself, I'll get one object detected and get the box coordinates, such as the bottom leftmost corner of the box's coordinates within the frame, along with the size and the height and area and width, as well as a confidence factor. So that was this application, but this could be used for just about any application that has a UART to get those coordinates up to the cloud. I'm going to go ahead and show the Terra term as well, and we're going to reset this board. So I'm going to pull power from the board. Which was basically an abrupt ending. We're going to insert power back. The board will reboot, and we'll start getting telemetry flowing to the board in just a moment. So I've got myself in frame, and we're starting to get that telemetry back in. So that concludes this video. I wish you the best in your journey, and hopefully you have a fantastic experience.